You know, every single day, we all perform what feels like a little act of magic. We type a website address into our browser, we hit enter, and bam, the website just appears. It feels so instant, right? So seamless. But behind that simple action is this incredible high-speed journey happening across the entire globe. Today, we're going to pull back the curtain on that magic trick.
I mean, seriously, have you ever just stopped for a second and thought about what's actually going on in that split second? It's not magic, of course. It's a brilliant, brilliant system. And in this explainer, we are going to solve that mystery together, step by step.
Okay, so here's the most important thing to get. We humans, we think in words, right? Like google.com, super easy to remember. But computers, they talk in numbers. To connect to Google's server, your browser doesn't actually need the name. It needs that specific IP address, that long string of numbers you see on the right. And that is the big puzzle the internet has to solve every single time. And the hero that solves this puzzle for us is called DNS, the Domain Name System. Think of it as the internet's official translator. Its entire job, its whole reason for being, is to take that friendly name we type in and track down the exact numerical IP address your browser needs to make the connection.
You know, the absolute best way to think about DNS is like a giant global phone book for the internet. It's just like your contacts list on your phone. You don't memorize everyone's number, you just tap on their name. Well, DNS does the exact same thing, but for literally every website out there.
So where does this lightning-fast search even begin? Well, the smartest place to start is always right at home. Before your computer shouts a question all the way across the internet, it first kind of whispers it to itself, just to check if it might already know the answer.
See, your browser is pretty smart and efficient. It keeps a little temporary memory of recently visited sites, and we call that a cache. So the very first thing it does is check its own cache. If it finds the IP address right there, perfect. It can skip almost this whole journey and jump right to the end. But if it's not there, well, that's when our real adventure begins. Okay, so when the browser's memory comes up empty, it passes the question on to the next level, a DNS resolver. This is usually a service run by your internet service provider, or maybe a public one like Google's famous 8.8.8. The resolver is basically like a super librarian whose only job is to go out and find the answer for you no matter where it is. And this is where the quest really kicks into high gear. The DNS resolver doesn't just magically know every address. No way. Instead, it has to follow a very specific path, hopping between a series of servers, each one more specialized than the last, to hunt down the information. Let's take a look at the map for this journey.
So here's our game plan. Our request, which is being handled by our trusty DNS resolver, is about to make 3 critical stops. First, it's going to go to a root server, then to a TLD server, and finally to the authoritative server that's holding the prize.
Our first stop is at the very, very top of the internet's food chain. There are only 13 sets of these root servers in the entire world. They're like the master index. Now, they don't know the exact IP address for google.com, but they know exactly who to ask next. And this is pretty much what the root server says back. It looks at the very end of your request, the .com part, and goes, I don't know the full address, but I know who handles all the .com stuff. Go talk to them. It doesn't give us the answer, but it points our request in precisely the right direction.
Which brings us to our next stop, the TLD server. TLD stands for top-level domain, and these servers are specialists. There's one for .com, another for .org, another for .gov. You get the idea. We've just been sent to the .com TLD server, which manages the records for every single .com website in existence.
So the TLD server gets us one step closer. It looks at google.com and says, okay, I don't have the IP address myself, but I know the specific server that is the official source of truth for the google.com domain. And then it points our resolver to its final destination.
And here we are, the end of the line, the authoritative server. This server holds the official, definitive DNS records for that one specific domain. This is it. Our search is over because this server has the treasure we've been looking for the whole time. And there it is, the treasure. The authoritative server finally responds with the answer, the numerical IP address. Our DNS resolver has done its job. Now it's just a matter of getting that info back home. So the epic search is over, but we're not quite done. Getting the answer is only half the battle, right? Now that IP address has to make the return journey all the way back to your computer so the real magic can finally happen. But before it sends it back, the DNS resolver does something really clever. It stores, or caches, a copy of the IP address it just worked so hard to find. Why? Well, so that if you or anyone else using that same resolver wants to go to google.com again in the next few minutes, it doesn't have to do the whole trip all over again. It can just give the answer from its own memory. So smart. And at last, the resolver sends that IP address back to your web browser. Now, with that crucial piece of the puzzle in hand, your browser can finally open a direct line of communication with Google's web server and say, "Okay, send me the web page." Wow, so we followed that little request from your keyboard all the way across the internet and back again. Let's just do a quick flyby of the entire sequence to see how all those pieces fit together. Okay, let's put it all together real quick. You type in the address. Your browser checks its local cache first for a shortcut. Nothing there? The request goes to your DNS resolver. That resolver then goes on a journey asking the root server, which points it to the TLD server, which points it to the final authoritative server. That server provides the IP address. The answer travels back to the resolver, which saves a copy for later, and then finally gives it to your browser. And only then can your browser actually connect and load that website on your screen. And here is the most incredible part of this whole thing. That entire 8-step journey, hopping between multiple servers, potentially spanning the entire globe and back, all of that happens in the blink of an eye. We're talking just a few milliseconds. It's an absolutely staggering feat of global engineering. So, the next time you hit enter and a website just appears, maybe take half a second to appreciate that invisible, lightning-fast journey that just happened. It kind of makes you wonder, doesn't it? What other incredible invisible systems like DNS are quietly working all around us, powering our modern world?